Okay. Thank you very much. Very much. I appreciate you inviting me to join in for a little talk this evening. This is a subject actually is sort of near and dear to my heart. I've been at it for the last 20 years or so. So let's just start with it. We're going to talk about low frequency and the medium frequency amateur bands, the new ones. Of course, they're not quite that new. You'll see, I think they date from 2017, so we've been around for a few years. But most amateurs are not acquainted with it, and they're not operating down that way. I'm hoping I can convince somebody to join us, come and join us down there. But anyway, I'll take you through. Now, one thing I wanted to point out on here is that the slides that you'll see tonight, I plan to put them on my website tomorrow the next day, which is antennas by N6LF. So if you want, no need to take notes. Take care, guys. Okay, now let's see if I can make the buttons work. Aha. First of all, I just want to remind you that we have the spectrum, just for arbitrary for convenience, we've divided it up. We have very low frequencies from 3 to 30 kilohertz, and the low frequency at 30 to 300 kilohertz, and what we call MF, the medium frequency, from 300 kilohertz to 3 megahertz. Now, of course, in the MF band, we've always had, not always, but for a very long time now, we've had 160 meters. That's the medium frequency at 1.8 megahertz. We have now, today, a second one. It's okay, let's push the button here, there we are. Okay, and so we have a second one, which is a 475 kilohertz, and then we have one, the low frequency band at 137 kilohertz. Yeah, I can't read that anymore, so I'll have to turn around, unfortunately. Let me go this way. First of all, I want to give you a little history, okay? I was not there for the original part of the history, but I remember some of them. First of all, I wanted you to understand is that ham radio and radio itself really got started only very late in the 1800s. In fact, the story starts really from 1900 up until the First World War. Okay? And the first thing we did was to try to organize it, to have some kind of conventions, to try to discipline it. Because it was a wild time. For the first 15 or 20 years, okay, radio in general was the Wild West. Everybody did whatever they could, and every day they were inventing something new. So the first thing we did is that they held a radio conference in Berlin, actually in 1906, with the effect taking in 1908, where they defined, said, look, we're going to use 500 kilohertz as our distress frequency. Okay? So that was really the beginning of regulation. Now, of course, regulation, that catches on. So one of the problems we have is that the amateurs of the day often have better equipment and bigger stations and stronger signals than the commercials. And it was not, and especially the military. All right? And to be honest with you, the amateurs became a true PETA. Total pain in the ass. Okay, we were a bunch of bad actors at the time. So what happened is about 1910, 1911, okay, the Congress got busy and said, well, look, we're just going to outlaw these turkeys. Okay? So ham radio in about 1911 just damn near died. Okay, it was very close. Turned out it was the Navy that saved us. They saved us because they said, hey, we need a wartime reserve of radio telegraphers. Okay, so they went to the Congress when they passed the laws, and they had the Radio Act of 1912, okay, which defined a lot, but the compromise was, you guys, you got to stay at 200 meters and up, okay, or I should say, and down in wavelength, okay, because most of the activity was below that, which that 200 meters is 1.5 megahertz. That was considered very high frequency. There's not a lot of commercial activity in 1912, okay, in that area. So at that point, that was this close to no more ham radio, okay, but that particular law. So in any case, the Radio Act restricted us, and that meant that the low bands below 1.5 megahertz have been denied to us for almost 100 years. Okay. There we go. Okay. first of all, there's lots going on, you know. There's a very good reason why they want to chase us out of town, okay? You know, below 500 kilohertz was really busy. The Marine radio telegraph and the Navy was in there. We had time and beacons, navigation systems. It was very, very busy for about 90 years, that whole spectrum, okay? Which is from below, we had the broadcast band and then down to the broadcast band, okay? So, in particular, the maritime band was 415 to 526 kilohertz. Now, of course, I have some personal feelings about it because I was, as a naval reservist, I was radioman third, so I was operating down region, okay, as a Navy radioman. And also later on, as an operator, I was a shore station operator out on Anahuac Atoll. Okay, so for me, I had actually been there before, but not as an amateur. Okay. Now, the point is this, is that about 1995, the world had changed. Okay, it's a very different world. And I have to tell you this, I'm a creature from another world compared to where we are now. Okay. The ham radio that I grew up with 73 years ago is almost unimaginably different today in most ways, but not all. Okay. In any case, about 1995, I finally reached the point where all these services that they've been providing, okay, had been busy. The beacons, the Navy operation, the Marine, all that had all been transferred to satellite and some HF, but most of it had gone to satellite. And finally, at one point, the Coast Guard said, hey guys, it's over. The Marine radio band especially, 500 kilohertz, if you're gonna sink, you're gonna choose another frequency. So they shut it down. And that was the key point. Okay? At that point, okay, somebody said, can we do something about this? There's a lot of spectrum down there we haven't had any access to. So here's what we did. Okay? Now, what we did is we took the experimental license route. Okay? Now it took 20 years, okay, from the mid-1990s until almost 2020. Okay? Now, the initial thing we did through the ARRL was to apply for an experimental license. We were Whiskey Delta 2, and what was the call sign? Yeah, X-Ray Sierra Hotel. All right? We got an experimental license, and we began operation in 2006. Okay? I want to emphasize that ours was not the only experimental license. There were half a dozen others just as individuals. So there were a bunch of us jumping on the same bandwagon. Now the difference was, of course, we were sponsored to a certain extent, but there were a lot more of us. Okay? We started with 23 stations and with more band. We had from 495 to 510. We were allowed to operate on 500 kilohertz, but we agreed, we say, look, that's for the legacy stations. We stayed away from it, we stayed above it and below it. Actually, mostly the initial operation was above 500 kilohertz. All right? So, a little later, we expanded to 45 licensees, and we had an additional band, which actually, if you look at those numbers, that included one of the new bands we got. Okay? So, we started in 2006. Ultimately, and I was doing the logging. I had all the logs for the ARRL license. They all came to me, and we recorded all the transmission time. And in total, we had about 300,000 hours on the air. Okay, and nobody complained. Okay, that was the key, because then what we did is we went. Okay, the ARRL went to the work. Work 12, which is actually in 2013, and did the allocation battle. Okay, and there was a lot of resistance. Okay, but first of all, there weren't enough interests who wanted to operate there then, and second of all, we've been nice. Okay, it wasn't like 1912 where they were out to get rid of us. Okay, so you might say we learned a lesson the first time. Okay, so that's what happened. They gave us the authorization. Now, you notice that says 2013. What does the next one say? Oops, so here are the lands scattered across. Okay? Here was the problem. is that our FCC took 4 years, okay, to give us the actual allocation, okay? And so the actual operation began in October 2017, and we were granted 2 new bands at that time in the US. I'm going to point out that throughout the world, we were joining come lately. Some of the other countries, particularly the Canadians and the Europeans, were actually on the air ahead of us, okay, had the authorization. Now, these are available to everybody, by the way, general class and above, okay? So they're wide open, you don't have to be an extra class or anything special, all right? And the 630 meters is 472, 479, okay, so we have 7 kilohertz. You think, ooh, all that bandwidth, okay? But if you really take a look at the 2200 meter band, it's only 135.7 to 100. It's 2.1 kilohertz wide. So here we have this brand new band, 2.1 kilohertz wide. And you say, what the good is that? Okay. But it turns out that the only way we communicate on these bands now, or because of the power limits, is digital. So if you're using 4 millihertz signals, okay, you can stack a whole lot of them in 2.1 kilohertz. So that has not been a major restraint, okay? So let's do it. Let's have a look here. Okay. Now, here are the limitations that we currently work with. 630 meters, we're allowed to radiate, 5 watts. Yeah, not much. Another reason why we do digital, but I mean, we can do things you wouldn't hardly even imagine. So, on 2200 meters though, we're only allowed to radiate 1 watt. And you notice this, we have this funny business here, this EIRP, okay? Effective isotropic radiated power. So maybe I should just take a moment and explain that, hocus pocus. An isotropic radiator is one that radiates uniformly in all directions. Radiates a sphere. There is no such thing, but the assumption is this, is that if you radiate 1 watt, okay, if you integrate over that sphere, that's what you get, okay? Now, for our purposes, though, we have to convert that to actual transmitter power. What do you actually allow the antenna to radiate? So the point is this, as soon as you take your antenna and you put it over ground, you're only radiating the power into a hemisphere, not a sphere. So first of all, that's 3 dB of gain. Okay, and then a vertical, if you look at it, it has another 1.7 dB of directivity. Okay, so the problem that we have, okay, is that our powers are actually reduced by about 5 dB down from the actual radiated power, the power radiated by the antenna. Okay, so that's the problem. We end up actually radiating about 2 watts on 630 meters. Sounds pretty grim, but it's not so bad, not so bad. Okay, you're allowed to do whatever you want, basically. That's one nice thing. If you think you can radiate it, and you think somebody will decode you can use it. Okay. Now, here are some of the common misperceptions. The bands are too narrow to use. Well, they are if you're thinking single sideband. But if you're thinking something like FST 120, where each half of the exchange takes 2 minutes, okay, and you're running, in millihertz as your bandwidth, okay, it works just fine. Okay, we have, in fact, right now what you find is that even when we're quite busy at night, with many as 15 or 20 stations radiating, they're all concentrated very close by, all within about 200 hertz of each other. And there's no interference, we don't have a problem. Okay. So, next thing you hear about the low power. Well, let me tell you about the low power. Okay. 137 kilohertz, I consistently was able to work VK4YB, okay, using, again, digital, but I was able to work, we had two-way QSOs using FST 120, okay, which is, we went to try 60, but that didn't work, we had to use 120, So it took 2 minutes for each way. Okay. And of course, the man-made noise levels and make it impossible to hear. That's not true, but it does make life difficult. It means that you've got to stop and think about your receiving antennas. Okay? Now, the other question is this: is that most of you live on small lots. The idea is you can't put up a decent antenna on a city lot. That's not true. It's not easy. Okay. But it is perfectly possible, and the number of the people have done it now, to build an effective radio, particularly on 630 meters, that will fit on a city, a 60-foot wide, 100 foot or 110 foot lot. So, and actually be communicating. That is, it is being done daily. Okay? And the other thing, of course, which people think about is that there's any radio equipment down there. Now, for me, of course, getting on the low bands was great. I came from a world where you built everything if you wanted it. Okay? And 73 years ago, there was commercial ham here, but I didn't have any of that. Okay? Most hams didn't. Okay? The fact is this: is that we now have gear. For example, I use the TS590s. In fact, I'm trying to remember what I say next. I've already made this point, yeah. Okay. Excuse me, I don't have it all memorized worth that. Right now, I just mentioned that we have taken the VK4YB on 2,200 meters. So that's perfectly possible, okay?
Rudy, did you tell?
Oh, I'm sorry, yeah.
Did you tell them where VK4B is? Where VK Australia?
Oh, VK4, yeah, I'm sorry. That's Eastern Australia. Okay. Oh, I figured you're all DX hounds. Everybody's a DX hound. Everybody's working Bouvet right now, 3Y0. Come on, guys. Okay. Anyway, one of the East Pennsylvania station, NO3M, has WAS. We worked all stations, and of the 50 states, excuse me, he has 38 of them on CW. He and I came very early. He and I got on and completed one of the first transcontinental, I guess, CW contacts. Okay, so you can do a lot more than you might think. Okay, now where we go. Now, which brings us back to the old rim. Why do you want to follow this? And I have to be honest with you. For me, it was natural. Because I grew up in a world where you had to build things. It's fun. That's how you do it. And that really is a big part of it. Okay? If you want to build antennas or equipment or that sort of thing, it's a challenge. Okay? And you just don't go down to have radio outlet and have parts all in a sack and bring them home. It doesn't work that way. It's not impossible at all. But it's for people who want to actually do a little, perhaps, old-fashioned radio, okay? Now, it's a very different business. One of the things that I do quite often, oops, I pushed the wrong button. It did something. Can I go back? Okay. I was trying to push this button. One of the things that I do, and I think one of you are already, I do boat anchor recoveries. One of the things that during World War II, the Navy, the U.S. Navy, had this tremendous radio telegraph network all over the world. Most of it down below 500 kilohertz. And they had built some beautiful receivers. These 70-pound monsters, well, I've got a half a dozen of them, okay? And they work today really well. It's really something to see. This 1937-38 design plugged into a computer. It works. Okay? Anyway, and again, most of it is digital. The FST signals. Okay? I don't know of anyone operating FT8 down there. You certainly could. We just haven't been doing much of that. Okay? But it would work. But the thing is this, FT8 is roughly equivalent to CW. So most of us try for the CW first. Now, one of the things which I strongly suggest, if you particularly want to do some listening, is start by listening with whisper. We use every night, there are a number of stations on whisper, particularly 630 meters, okay? Myself included, not every night, but usually I try to get on 3 or 4 nights a week, okay? So that is a very good thing. Now, I don't know how many of you know about whisper, but basically the message you're receiving, okay, is just very basic information. Huh?
You got me again?
There we are. Very basic information, the time, the call sign, frequency, okay, but power and so forth. And the signal to noise ratio. That's really, this is a quantitative measurement of what your signal is doing. In other words, what you're doing is you're transmitting a signal, people are receiving it, it goes into the internet, and it comes back out, and it tells you quantitatively how strong your signal was. So that's a particularly useful way. This is just to give you a picture of one evening from my place. Okay, this is my station being heard. I keep pushing the wrong button. There we go. Okay, showing here I am, and I'm being heard all over the country, and that happens every night. Okay. I have typical night. I will get between 85 and over 100 reports, different stations, reporting stations, all the way from New Zealand and Australia and all over the US. I have not yet, however, been reported from Europe, which I hope is the future sometime. Okay, so this is very typical evening. Yeah, button I'm pushing. Okay, very typical evening. You'll have 10 to 15 transmitters, 40 or 50 stations receiving, although in my case, many an evening I had, in fact just this week, had over 102 stations reporting me. Okay, and there will be any number of stations, mostly in the Midwest and East Coast, who are just doing QSOs with FDS 60. On 2200 meters, there's usually a couple of stations, okay, 2 to 5 stations transmitting. So the band is not dead, but there is not nearly as much activity as you would hope there. Okay. Propagation, well, yeah. Okay. Now, let me just tell you about receivers. Okay. I use a TS590. Okay, it's a really good receiver. It really works down there. Okay, it actually was designed to operate at these frequencies, although it only gives me 2 milliwatts. But the point is this: is that many HF transceivers will go down to 100 kilohertz. Okay, one of the problems though that you have is that they often do not have good signal to noise ratio, particularly when you get down to 137 kilohertz. So it's only really the newer HF rigs which are good receivers down to 2200 meters. Most of them work just fine down to 630 meters. Yeah, this is like sick. All right. There we go. Okay, down conversion. So I'm using this one. There we go. So this is it. Now I get out of my transceiver, I only get about 3 milliwatts. But it's all modulation modes. Everything is there. Okay. So what I have is I have an amplifier. And there it is. Be careful this time. There's the little amplifier that I use. And, okay. Mine happens to be very serendipitous. 25 years ago, I went to Seaside. Went to the flea market at Seaside. And this was sitting on a bench, and it's an amplifier that has about 55 dB of gain. It's a laboratory amplifier, and it goes from 10 kilohertz to 800 kilohertz. This was way before any thought, okay, that I would be operating, okay, at the low bands. Okay? And it was $50. And I said, well, I'm doing power supplies. I can use it to test ferrites. So I gave him the $50 and bought it. I was dead lucky. You know, pure serendipity. Here I had this amplifier. The day after the authorization from the FCC, man, boom, I'm on the air. Done. But you don't have to. There's lots of kits available now where you can get multi-100-watt amplifiers. Okay. There's a lot of stuff available which was not when we started in 2006. Okay. All right, there we go. Now, first of all, my advice to all of you is to keep the microphone close. Okay, is just start by listening. That's why I said by listening, I mean listening digitally primarily. That's why the whisper is a very good place to start. Okay, because there's activity, there's lots going on. Okay. Okay. All right. So what is there to listen for? Well, not just on the handbands. You know, we do have still the non-directional beacons. You have distant broadcast stations. But the one thing I would suggest you do, if you're not aware of it, is there is this software, K1JT. That's all the Whisper and the FST and all the FT8. That's all. If you guys are doing that stuff, then you must know this website. That's where that comes from. Okay. Atmospheric noise. Yes, it's really grim, but we're still making it. Because of the ability to operate extremely narrow band, that's how you beat the noise. What we have, here's this curve. If you look at it, atmospheric noise, which is at a level 0.5% of the time. That's the worst that you would expect to see. And this is the best you'd expect to see. And you'll notice there's 50, 60 dB difference in noise levels. But the key item is this is a megahertz, and this is 100 kilohertz. Excuse me, let's be careful. No, not my vision.
Get into the port.
This is megahertz, that's 100 kilohertz. Anyway, the point is this, is that when you, in this region, okay, all right, in this region, the noise is going way, way up, all right? So, we're, all right, that's the point I'm trying to make, okay, is that here is the normal HF ham bands, and this is what's going on. So yes, it is noisy, there's no question of that. Okay. Okay. Now, one of the things I want to emphasize is that the transmitting antennas are a different business from the receiving antennas. In particular, the standard vertical, which some variation of it, tends to pick up a lot of local noise. Okay. So for the most part, what we're using down here are loops. Okay. Horizontal loops, primarily, okay? Here's a couple of examples, okay? This is, there we go. Here's a nice loop right here. I think this is W7IUV is using it. That's probably about an 8-foot diameter loop. This is just a simple couple pieces of pipe, you know, with a piece of wire around it, okay? Now, here's what I'm currently using.
Wow.
What I did is I took an old surplus quad, 20-meter quad. It's got 8 arms on it, okay, and 2 spiders. So I just set the spiders off, so that they're crosswise. In other words, basically what I have here is here's one quad, and here is the other quad.
And that's how Rudy and I got together.
Sorry?
That's how Rudy and I got together.
Yeah.
He saw a picture of a quad I took down.
So, okay, this works fine. I also have a version where I just use the 4 of them. So, we basically use loop antennas for receiving down there, okay, because of noise considerations. Okay, here's just some little details, okay? And by the way, I plan to post all this stuff on my website for you. Okay. Good. Now, transmit antennas. This of course is ideal for those people that have the room. By all means, you know,
Oh, my neighbors will love me if I put that up.
there we go. You know, if you have the room, hey, go for it.
Hey, Gary, I'm gonna need you again.
I didn't hear it, I'm sorry.
It's a joke.
Oh, okay, very good. Anyway, the point I want to make is this, is that the problem is the wavelengths are so long. If you're around 2,200 meters, the wavelength, one wavelength is 1.37 miles, okay? That means that any antenna that you can imagine building, okay, will be very small electrically. Okay? That's the problem, okay, in designing antennas. All right? So that's really the fundamental. Okay? But there's some advice. This problem has been solved before. Okay? This is what Woodrow Smith gave in 1947, which represented really, really beautiful advice. It says, make it as tall as you can, put as much top loading as you can, put a good high Q coil on it, and go for it, and a good ground system. Okay? And it turns out that you can prioritize this. Okay? And here are your priorities. I'm not going to list them all the way through here for you. But if you follow this through, you can have successful antennas. Right? So, for example, what do I have? Oh yeah, well, okay, here's the problem. The antenna will be little more than a capacitor with a resistance. Okay? And what you're going to find out is it's a very high, in other words, this number will be, the capacitive impedance will be very high. In other words, it's not a lot of capacitance for the frequency. Okay? It's a very high reactance. And this side of the coin, the resistance of the antenna will be very low. And that's the problem, okay? Because when you look at the efficiency, the way that it works is this. If this is the radiation resistance, and that's about 5 milliohms, and these are the loss resistances down here, okay? And they're in tens of ohms. The efficiency is 1 or 2%. But remember, because of the power levels that we're at, if you're able to generate 100 to 200 watts, which you can get kits for, okay? You only need to radiate about 1 or 2%. Okay? In other words, that's what keeps us going. Okay? I generally run about 120 watts or so. Okay? And I radiate the allowed 5 watts EIRP. Okay? Now there's all kinds of antennas. This is back to the Wild West, using all the tricks you can think of. For example, that's the wrong button, there we go. For example, you could just have a piece of wire, or you can have lots of wires. One of the interesting things that you discover is, for example, suppose you have this kind of a mattress up here. This is a capacitive loading. Whether you hook it here, whether you hook it there, doesn't matter. One of the things we're used to, if you have a regular dipole, where you connect into that dipole really matters. Okay, as far as the current and the impedance. Down here, at these frequencies, the current distribution is either uniform or a straight line. It turns out that it doesn't matter much, okay, where you hook it on. This is particularly important when you're doing the top loading. You can have one wire here, and a short wire here, and a longer wire over here. You can play all kinds of games, it won't work. Okay. Yeah. Okay. So be inventive. That's the other thing. Use anything that will hold the wire up in the air. I'm not a fan of trees for a number of reasons, but in actual fact, a lot of the people are using trees to hold the wires up. Okay. Now, first of all, this is my present antenna. What I have built is this, and this is actually, I think, version 3 or 4 of my transmit antenna. I have, you can't leave them alone. I have to take it down and put it back up again. But in this particular case, what I have here, we don't do that. it matters how I push the button. You know, that's interesting. Okay, what do I have is this is 80 feet of 4-inch diameter irrigation pipe. So, you know, got Pacific Ag, 2 40-foot lengths of pipe with a splice in the middle, right? Okay, and you really can't see them, but there are 3 sets of guys, or 3 guys, 4 sets of 3 guys, okay? And I use the Dacron, the black Dacron rope, works just fine to hold it up. And the other thing that I have on the top of it, which you can't possibly see in the picture, is that there are 8 top-loading wires. So this is an umbrella. All right? Okay, what I've done is first I made it as tall as I could. I put as much top loading on top as I could. And then I fudged a little bit. You see, because for the ground system, when I first moved, oh my gosh, it's been 14 years we moved to
14 years.
yeah, it's been 14 years. When I first moved to the new location, I have been very active on 160 meters. So I had a 3-element inline array on 160 meters. In other words, I had 3 of these suckers, okay, 80 feet high with a little bit of top load. And so I put down 3 ground systems, 64 120-foot radius. Okay, 25,000 feet of wire.
Wow.
Well, recently, what I did was I took 2 of them up. Okay, I took the antennas down because I wasn't really that interested anymore in 160 meters. I was really focused lower. But the thing is, I left one of the ground systems in place. So when I put this antenna up, which was really replacing one of my elements, okay, from that 3-element array, okay, I ended up down here with a nice large ground system on it. And so the net result is that, you know, I don't have any trouble radiating the legal on the power. Okay. And this is just a coil at the base. In fact, you can, if you look here, you can see, this is all the radial wires headed out. And this is, okay. Now I want to tell you that on my website, right here, there you will find 6 chapters on antennas with low bands. Okay? And there's 200-300 pages of material on how to design an LF antenna. Okay? Now, let's talk about the future, where I'm hoping will be much like the past. The reason is this, okay? The present power levels are really low, okay? And they really are restricting a lot of the operation, okay? I think if we were allowed to radiate a good deal more power, okay, I think the band would be a lot more popular, okay? And although radiating a lot of power it's difficult because the antennas are so short electrically. But I want to remind everybody about 160 meters. First of all, World War II, 160 meters disappeared. It was replaced with Loran A. For many, many years after the war, certainly when I got started, there was no 160 meters. Okay? And gradually we said, well, okay, we'll give you a little bit up over here, and you can run 100 or 200 watts or so. So over a period of many years, we recovered 160 meter bands. Okay? What I'm hoping is that if we're good and persistent, that we will be able to do something like that for the low frequencies. Okay? But that's for the future, that's for other people to do. But that's what history has been. I just want to let you know. There we go. Here's us, and there's them. So, okay, that's kind of I'm not sure how to go. Oh, you're right. Okay, I think that's pretty much a run through. Okay, I hope you. Do you have any questions? Okay, let's start here. I'm very hard of hearing, unfortunately.
We have a second microphone. Hang on. Do you have a calibrated way of measuring the EIRP?
What?
Do you have a calibrated way to measure the field strength or the EIRP?
No, I'll tell you what I do, is I estimate what the efficiency is from modeling and from measurements on the antenna.
Okay.
I'm only guessing, but my guessing is probably as good as anyone's. Okay? You know, it's not like a broadcast station
Yeah.
where you have 1 mile, you measure it, you know, you run it, you know. And even that is a guess, because you don't know the soil in between.
Okay.
Yeah. So in my case, I do it from modeling and the actual measurement that I've done. The modeling gives me the radiation resistance. Direct measurement gives me the total resistance, and I assume the efficiency is R sub R over whatever I measure.
Yeah, okay.
Any other questions? Hold on a second. Take a mic up.
Yep, so, very loud. The transverter that you use, what frequency do you use on the HF radio to transvert it down to these lower frequencies?
In this particular case, you know, I said transverter, but it's a direct. In the case of the TS590, the output is directly on frequency. In other words, I get 3 milliwatts at 475 kilohertz directly, okay? Now, when I say transverter, there's something going on inside how they get there. But the TS590 will provide you a direct signal at the frequency you want to operate at. Now, there are other transverters probably, I'm sure, available, okay? But I haven't had to use them.
Yeah. So, I mean, an ICOM, for example, it really is not gonna transmit below 160 meters, you know?
Yeah.
So, but you can receive the 630
That's right.
meter band.
That's right.
But I was wondering how any one of us would take our radio and build one of these kits,
Yeah.
you know, to.
You know, I have to
Yeah.
say that I really don't know the detail of what's available out there.
Mhm.
You know, it comes and it goes, that's the problem, because it's such a small market. All right? It's a really very limited market, okay? You know, and I've been spoiled, you know, I have one of the TS590s, and there are a couple of other of the newer receivers that read transceivers, which will give you the kind of signal I get from that, okay? Yeah. But I know, for example, I have a 1000 MP, when the ISU 1000 MP which was my 160 meter station, and it absolutely wouldn't do it, and it was a terrible receiver on 137 kilohertz. I actually measured the noise figure down there, okay?
Yeah.
Okay?
Yeah, why the low EIRP limits? Why are the limits for EIRP so low?
Because that's all we could get.
So they just start at 2 watts and say that's it?
They just start at 2 watts and say that's it?
That's right, yeah.
Okay, any other questions? No other questions? I have a question.
Yes.
So, before Ham's got their allocation, recent allocation for medium wave and for long frequency, there was a group that was non-licensed. I think they called themselves loafers. Is that
Yeah.
correct? Are they still active?
Actually, okay, I was never part of that group, the loafer group, and some of them they did not have an experimental license, but they were allowed to do a certain amount of operation down, I think, around 100 and some kilohertz.
Yep.
Yeah, but I never knew much about them. Okay, but they were, I knew very little about them. Okay.
Good, thank you. Hold on.
Yeah, they had, I think, very little impact on what we were doing.
I was wondering about the power amplifiers used in the 220 meter band. I was wondering about the power amplifiers, and it's the sonic performance of a lot of audio amplifiers now that are directly coupled might actually go into that band. And I'm wondering if any of the other users are using a high performance audio amplifier to actually amplify that
Well,
120
actually,
kilohertz.
I think we mentioned something earlier. You know, you think about Macintosh amplifiers, some of these may be possible for 137 kilohertz. I don't think it would go to 472 though.
No, I don't think so, and it would have to be a solid state that was direct coupled.
Yeah.
So not an old
Yeah,
Macintosh,
and,
but,
you know, I'm not an audiophile, okay? In fact, most of the people that I know of, they're using some kind of a switcher, what we call a Class D.
right.
Because all the modulation modes that are currently being used, okay, are frequency shifting, okay?
Right, so you can use a Class D amplifier, it'd be a lot
You
more
can use a
efficient.
Class D, yeah, which is just basically a switcher. And that's what most of the people use. I happen to have a linear amplifier, okay? Which actually puts out harmonics that I have to filter.
You wouldn't if you didn't push it so hard.
No, not really. The problem, I looked carefully at that, and even at low levels, it still has some second harmonic, because part of it is unbalanced. Nice. Okay, anyway, I don't push it very hard. As a matter of fact, it's a 500 watt amplifier, and I'm only keep pushing it to 100 watts. Yeah,
I stand corrected.
yeah.
Hold on a second, Tony.
Since most of us has never touched low band, low frequency, can you tell us a little bit about the characteristics of the bands? When they become active, is there seasonality? Any particular times you'd like to operate? I imagine it's probably after midnight in a lot of places you'd like to talk to. isn't it?
When are the bands active? When are the bands
Yeah.
active?
First of all, for DXing, anything over a few hundred miles, okay, it's at nighttime, okay, for sure. Great line is very prominent. Okay, in fact, that's how I worked VK4YB. We were gray lining it, and you could actually, you know, we would just sit there and transmit, and then boom,
Done.
it was being like I'm being 6 meters, I think it is. Okay, you're waiting for a meteor shower. So it is strictly nighttime work for any distance at all. Yeah. Now, what I see when I look at the whisper signals, okay, you can see where people are receiving you and other people are transmitting from around the country. And that gives you a really good feeling for the propagation, because it's a quantitative measure, okay?
So I had a question about magnetic loops that are typically used, 1/10 of a wavelength or smaller with a big capacitor on it. Can you do that on a?
Well, no, the problem is this, is that scale it up.
Mhm. Well,
Okay.
still
Let's go from 20, let's say you have a 8 feet in diameter and 20 meters.
No, I'm thinking big, 63-meter diameter circle, you know,
You know,
big
the
loop.
problem is, you know, I've actually tried to dream about making something. Okay? I'm thinking about you know, I got a whole bunch of that 4-inch pipe, you know, and it is possible, but I think I can do vastly better by putting a little of the pipe in the air.
Yeah, I was thinking like a you know, big horizontal loop that went around a couple of times, like your transmitter loop, and then a capacitor.
I don't know how it would propagate. The problem is most of the propagation is vertical, vertically polarized.
Yeah, so, well, in fact, it was a 1/10 of a wavelength or less, you know, then it's gonna propagate off the
Well,
edges.
remember,
of
when the wavelength is mild,
Mhm, right?
okay?
Well, people have big I have 10 acres, you know, I can run around
I
the
wish
trees.
you luck.
Go around.
I've certainly given it some thought, but what you find is that the efficiency kills you. And
Yeah.
also the narrow band kills you. In fact, my antenna, one of the problems that I have with my antenna, even though it's relatively inefficient, okay, and there's a lot of resistance burning it up, okay, my operating bandwidth is only about 2 kilohertz. I can only move around a couple of kilohertz at a time, okay, without retuning the antenna. It's a very high Q antenna, okay? So that's part of the challenge, which reminds me, where's the other Gary?
Gary.
Rondo,
Gary,
7NX.
There he is.
There's Gary. Gary, we gotta talk about how to make a remote tunable capacitor. Using a stepper motor. Okay?
Yeah,
That's-
we got, well, any more questions? Maybe time for one more?
How about loading up a bridge?
Bridge.
I'm being facetious, but it could be useful, I mean, on a portable
I'll
launch.
load up a bridge, make a bridge into an antenna.
Oh, yeah, you could. Hey, use your imagination. Actually, that's a big part of operating down there, is looking at the situation, seeing what can I do now? I'm big on modeling, okay? In this situation where you have a completely unconventional antenna, unconventional location, okay? You really need to model it, using the modeling. And I use it all the time to get some idea, is this going to work? Okay?
Okay. Rudy, terrific. That's a little memento of coming to speak tonight, so pin for your hat or your pocket, very good. Okay, we're